In this video, we are going to show how to 3D scan bones. So to start with, we are going to use the Creaform HandySCAN 700 Elite. This is a blue laser 3D scanner. It has 14 laser lines and a single line mode. So you can see I have the bone just elevated here on a couple of blocks. And then I just have some artifacts with targets on them around the bone. This scanner requires targets in its field of view at all times. These are for positioning only. So you just scatter something around. You could put them right on this little rotary table. You don't have to use a rotary table, but as you can see, it makes it very nice and fast to be able to move around and scan without you having to walk around the part. Now, if you're doing something large, this wouldn't make sense, but for most bone models, this would be fine. So as long as you have those targets in the field of view, you basically just work your way around. You can see on the screen those 7 laser lines picking up the shape. And then you see here I'm going into what's called single line mode. That really helps getting down into small holes, small cracks, little valleys. It focuses the sensors on a single line and zooms in. And you can jump back and forth from that single line mode back to the normal mode just by double clicking the button there on the scanner. So you just keep going around and digitally spray painting it, as I call it. You're basically just trying to make sure you have everything. It doesn't hurt to go over the same spots over and over. And it's a visual look as you're scanning. It's all in real time. You'll notice the laser light, you'll see it red, sometimes green, sometimes blue. That's just telling you if you're too close, too far away, or if it's green, that means you're in the right depth of field. So that's it. I hit stop scan. And now I'm going to add a second scan because we want to flip this bone over so we can get the other side of it. So I just flip it over, make sure my blocks are in a way we don't want the part moving around while we're scanning. And now we tell it, go ahead and scan again. So now we'll do the bottom side. And you can see how fast it picks up the data. I believe this scanner is around 500,000 points per second with those 14 laser lines. And again, it's just visual. You just look at it and make sure you have all the data. You can stop at any time and zoom in, look at the scan data, see if you've missed some spots, and then go back and scan again. But you can see it's pretty fast. You get immediate feedback. You'll also notice, it might be hard to see, but sometimes you'll see the bone is yellow and then it turns teal. Based on whatever resolution you're set at, and this will go down to 0.2 millimeters or 200 microns, it'll be yellow and then it'll turn kind of teal. When it turns teal, that's telling you you have enough scan data based on the resolution you set. I believe we're set here at 0.5 millimeters. Again, that's resolution, not accuracy. I'll talk about that, but 0.5 is usually fine for this. But if you'd set it down lower to 0.2 or 0.3, you would see it takes longer to turn teal because it's telling you don't have enough points yet to do the actual scanning. You don't have enough data there to do the scanning. Now here I'm grabbing a couple more targets just to throw kind of on the end. So you can add targets at any point. I just didn't have enough out there as I was articulating around. So you can add more targets. If you lose a few targets, it's not a big deal. You can actually even delete them out of the scan data file if they became lost. But typically you don't even have to do that. So again, I'm just working my way around. You can change the resolution even after you scan it. You just have to make sure you have enough, scan data there to cover the whole part or the whole area. Enough density essentially. So you're just filling it in until you have enough density based on whatever resolution you've set. Okay, so you can kind of see over here. I just need to go in. You see it went from that yellow to that teal, telling me yes, you have enough data based on your current resolution. So again, you just keep working yourself around it until you get all of the data. And again, it doesn't hurt to overscan it. It's not going to hurt anything. You hold the scanner about 10, 12 inches away to do the scanning. And then I'm going to long hold the button and tell it I'm done. So now we can review the data. And next we'll align and put the two data sets together and merge them. Okay, now that we're done 3D scanning, you can see we have the two files here. Now, obviously, when we add a second scan, they're not lined up. Now, I'm in the VX Element software. This is what's actually called VX Scan, part of the VX Element software. This is included with the 3D scanner, so there's no additional charge to use this. So let's hide one of the scans and show just the first scan we did. And let's go ahead and, well, first thing we want to do is clean it up, obviously, because we don't want all this other stuff. And we have some really nice selection tools here. You can window in, you can paint, you can select like curved or flat areas, etc. Part of the reason I like to elevate the part is it makes it very easy to separate the part from the rest of this data. So for example, I'm going to use the connect command, and basically where I pick, any triangles connected to each other get selected. So it's a very fast way to select what I want. And then up here, I can either delete or keep. I'm going to say keep and hit OK. So really, with a couple of clicks, I have separated. We can turn off our targets just for visual look. I have separated that scan data from everything else. I can hide that. I can turn on the second scan and do the same thing. Now, if it was connected a little bit, you can go in with some of these other tools and separate it. But usually, if you do a good job setting it up, you can do this pretty quickly, and usually just a click. Okay. So now I have my two scans. Obviously, they're not aligned. Now you could have 2, 3, 4, 5. Typically, we don't have more than 3. 2 is the most common, but every once in a while, sometimes you have to just the shape of the part might require 3. So the next thing I want to do is an alignment. We've got all kinds of alignment tools. We're going to use the surface best fit. Over here, we're going to click manual, and we're just going to click a couple common points. So what I like to do is get these oriented in the same kind of general orientation. And we're going to pick 3 common points to get started. So we'll pick here, here, and here, and we'll do the same over here. Pretty straightforward in the 3D scanning world. You basically are getting it close. You then hit best fit. It will align them up, as you see here, and I'll say that looks good, and we can hit OK. You can pick more than 3 points, but usually you don't have to. Now, right now, there's still 2 separate scans, so now I'm going to merge them together. This is where I can change the resolution. So even though we scanned it at 0.5, half a millimeter, and again, this is resolution, not accuracy, I can come in here and I can say, you know what, let's crank it down to 0.35. And we have a thing called smart resolution. I'm not going to go do it too much, but it optimizes the mesh based on curvature. So it'll put more tighter triangles in curved areas and less in other ways. It's kind of like decimation, but it does it automatic. Now, the other thing we can do, let me turn this on, is we can do things like reduce noise, sharpen edges, smooth boundaries, etc. So we can do some nice post-processing here if we want, or we can turn this stuff off. Like, let's say I want it's a bone, it's got rough areas. Maybe I want to see that in my scan data. I can turn that smoothing and off, and it'll have a more accurate finish. It'll be less smooth, but maybe that's what we want. We can slide this to fill any holes. If there's any holes on the part, there could be a few small ones somewhere. We can even click this watertight button. I usually don't use it because it does take a while, but it'll make sure that everything gets filled in. And then let's go ahead and hit accept. Now, the more of these things you click, the longer it takes to process. But it's, for bones and most things, it doesn't take long at all to process. It's usually when we're doing like a large vehicle or something like that. Okay, so that's it. You can see how fast it was, and you can see our results. So really nice looking data. Let me turn on the mesh so you can see it. Okay, and it might be hard to see here, but yeah, actually you can see it. So you see how we have much tighter mesh right in here, smaller triangles, and then bigger out here. So that's that smart resolution. It'll automatically keep tighter resolution in tight areas and make them a little bit bigger in areas that don't need so many triangles. So instead of having to crank the res way down and then do a decimation, it essentially does it for you. But there we go. There's our model. Now, I'll put a link to this file that you can download it in the description below so you can check it out. What did we end up with? Let's see here. Let me bring this scan details up, just seeing how many triangles. So we ended up with almost 1.5 million triangles on this part. So that's it. Now I can just export it as a mesh and save it out. So you have a few different formats you can use. I mean, the most common is STL, but you can do OBJ and some others. These are all mesh formats. Basically polygon meshes. So we'll go ahead and save it out, and that's it. We can also save the session file. That's kind of your raw Creaform file. If you ever want to come back in and maybe you want to change the resolution, maybe you don't need 0.35. So for example, I'll say, you know what, 1 millimeter is fine. I do not want or need this much detail. You just hit the finalize button again, and you're going to see it won't have as much detail. So it's a little bit softer, but we're down to 300,000 triangles. And let's do this too. While we're here, let's turn on that smoothing and just reprocess it again. So any of these things you set, you can see now it's even smoother. So again, maybe you don't want it to be so smooth and so fine. You can see what we've done. So you save that session file, you can go back and process and reprocess, change the resolution, change any of these settings and update it and then export it. So it's a really nice feature. Okay, next we're going to scan the same bone again. This time we're going to use the HandySCAN Black Elite. Now, the main difference is with the Black Elite is it has 22 laser lines versus 14. It also has the single line mode. So what you'll notice right away is it'll definitely scan faster. Now, on smaller objects, probably not a big deal, but it definitely will scan faster because it has more laser lines. I believe it collects like 1.2 million points per second, so about double the collection rate. You see me here in the single scan mode. That's pretty much the same. Now, the other key thing with this scanner, it is ISO certified and has an accuracy in the standard mode, or the standard scanner, the Elite scanner, of 0.9 of a thousandth or 25 microns. And there is a limited model that has an accuracy of 12 microns or 0.5 thousandths of an inch. So if you want to do dimensional inspection of things like bone plates and knee implants and 3D printed metal parts, you could use this scanner because of A, it has that ISO certification, B, it has a very high tolerance, or high accuracy, I should say, and it's certified to the VDI VDE standard, which is a standard most non-contact 3D scanners use. It's how they measure their accuracy. So if you look at some of the high-end systems like Zeiss and GOM and others, they all use that standard. So very, very high accuracy. And again, ISO certified. So same thing, we just work our way around, filling it in. Excuse me. This will go down to a resolution of 100 microns or 0.1 millimeters versus the 700 will only do 0.2. So first scan is done. We'll go ahead and do the next scan just like we did before. Really nothing changes. As far as data quality, the black versus the 700, they should look fairly similar. I don't think you're going to see a huge difference. Theoretically, the black will be a little more accurate. Now, if you're just doing bones, I don't really think it's going to matter. But if you want a scanner that will allow you to do inspection, if that's something, or just parts that have really fine detail for reverse engineering, smaller implants, bone plates with small holes, things like that. This would be a good choice. It'll also do a little better on dark and shiny stuff than the 700, just with newer optics and laser technologies. So again, we'll continue scanning this as you see here. But a femur bone like this should be able to scan it both sides in a couple of minutes, and then aligning the scan data, putting it together, merging it. It's the same with all the scanners, so we won't show that again because we just don't need to. But again, you can see how fast you go, and it's instant visual feedback. You should know when you're done scanning that you have everything because you can just zoom in and look around at the scan data. So that's pretty much it for the HandySCAN Black Elite. And again, higher accuracy, ISO certified, higher resolution, and 22 laser lines. Okay, next up, we're going to do a smaller bone. And for this one, I oriented it vertically, and then I'm using some vertical bars. So this rotary table we're using here just has threaded holes in it. This is just something we had made. And then I've got some 1/2-inch bars that you can see, vertical bars that have targets on them. We use this kind of setup to do like turbine blades quite a bit. So if you wanted to set up the bone more in a way you could do it in one setup, this might be how I would do it. We also use, you'll see on the foot bone here in a minute, kind of some long needles to hold the part sometimes. But this would allow you to kind of scan it potentially in one setup, either using something like this or like those needles you'll see when I do the foot bone. But either way, I mean, doing it in 2 setups, not a big deal at all. But if you want to just see a different setup where maybe you can get the whole thing scanned in one setup, you could do something like this. Now, I'm using the HandySCAN Black Elite here. This would be the same for the 700. I don't need to show both scanners each time. We've mentioned the benefits of the Black Elite over the 700, but either one would be fine. But I wanted to show more of a vertical application for scanning. Okay, for the smaller bone, I scanned it 3 times. So I scanned it vertical. Let me just show this. I just want to be able to show how quickly you can edit multiple sets of scan data. So I scanned it vertical, like you see here, but obviously the holder, the bracket, and the bottom could not be scanned just because of line of sight. So then I laid it on its side like that, and then also like that. So I just want to show you how quick we can take even 3 sets of scan data and clean it up. So, for example, if I come in here and use that connect tool, well, you can see it's kind of all connected, right, because of that. So let's clear that selection, and then we'll come in here, and I don't have to be too fancy because I've got all this data captured in those 2 additional scans. So I'm just going to click that and delete it. And then we'll go down here to the bottom, same thing. And I have this select through on, which will just get everything. Hit OK. And that'll do that. Now I can use that connect command. And this time I'm going to just keep that. And then we'll do something similar on the second scan. So let's see, this one I might get away with the connect. Nope. Okay, so same thing. I really just need to separate where it's connected to this block. And delete that. And now I should be able to use that command. And again, just keep. And then finally, let's do the last one. So same thing, laying down. I just flipped it over. So again, same thing. Just delete that area. And then I should be able to just grab that. There we go. And keep. Okay. So I can quickly separate all the data. Now let's do that alignment again. And we'll use the same surface best fit method. So we come in here. I'm going to use the automatic this time. These are generic enough in shape that we may be able to get it to work. And let's do each one. And there we go. So we have all 3 aligned, but again, they're not merged yet. So we'll hit OK. Let's turn them all back on so you can see them. Okay, and we can turn off those positioning targets. Just makes it easier. So again, they're all aligned. Now we go to the merge scan. Again, maybe I want to crank my resolution down a little bit. I want to turn this to custom. And again, I'm going to turn off that noise and smoothing, but that's totally up to you. I'll go ahead and slide up the autofill holes a little bit and hit accept. And there we go. There is our bone model. Looks nice. Everything looks good. And these are plastic medical models, so you're going to see, you can actually see some of some of the parting line on the part. So they're not real bones, but you get the idea. Okay, so now I'm going to export just like we did last time, mesh, and output it. So that's it. So our second one is done. Okay, and the last setup here, we've got a foot bone. And the problem with this is it moves around, right? So this is just a medical model, and it's all kind of held together with wire and so forth. But the point we're trying to make here is if you had something very delicate or had some moving parts, you can see these are those long kind of needle things I had mentioned. So I've got it suspended in a way where I can 3D scan the whole thing without having to flip it over, because if it does move around and I flip it over, the data is not going to align very well, obviously. So we'll use a setup like this with these pins or these needles. What's nice is they're easy to delete out of the scan data. You hardly see them in there. And same thing, we just work around. We've got those vertical bars in our line of sight, so it always has targets to track. And I've got it elevated up high enough that I can get, the bottom of the toes and get the rest of it. Now, bone models like this, the foot, as you know, they take a decent amount of time because, you've got just small gaps and small features. So we will use that single line mode, quite a bit to get in here and get all that data. But a model like this might take 5 or 10 minutes, maybe 15 minutes at the max. To 3D scan. Again, it's just working your way around and, picking up all the data. And again, you get that visual feedback to be able to see if you've missed few areas. And there's always going to be, on a model like this, there's just certain areas the scanner won't see down into. The good news is the sensors are fairly close together. So the closer they're together, the narrower of a gap it can see down into and basically see the laser and pick it up. So it does very well, probably better than most scanners as far as getting in and getting the data. But again, the idea here with this setup is setting up the part in a way that it doesn't move around at all, so that we can scan it all the way around. We just got to be careful as we rotate the rotary table. We don't do any jerky motions, but it's pretty stable in here and should be just fine. So again, we're using the HandySCAN Black Elite. Wouldn't be any different for the 700. But that's it. You just go around and get all the data till you have it captured, and then you're done. Okay, and finally, our foot model that you see here. Now you can zoom in. Let's try to select it. And again, by using those needles to kind of hold it, it does a great job. I don't have to go in there and try to manipulate and clean up the data. And so let's go ahead and hit OK and keep just what we selected. Turn off those points. Okay, so there's our... Now, there is a little bit of junk here. Might be kind of scatter data from that needle. I can come in here and just select that. Like you see here. There's even a command to get rid of what we call outliers in the software. Let's go ahead and just delete those. And a lot of times it'll do that automatic for us. Now, until we finalize, we're kind of in a low res mode. We haven't actually processed it. Oh, here's the other one here. And you've got some wires and things holding these models together that obviously wouldn't be in the real anatomy, but you get the general idea. So this time when we process it, let's use that watertight command. Okay, and let's see what it does. Again, those are the wires that hold it together. So let's crank our res down a little bit like we did last time. Let's go to custom. Let's try watertight and autofill. I guess if you do watertight, autofill holes gets turned off, reduce noise, and sharpen edges. So this, and then we can click removed isolated patches. That again will get rid of junk floating out in space. Let's see how this turns out. Okay, so you see it finished here. Let's take a look. Overall, I think it looks pretty darn good. So any areas, maybe some tight cracks where we just didn't have data, you can see it filled it in really nicely. So we have a nice watertight model. And again, there's some wires and stuff holding this together. I'm just going to leave that for now. theoretically, you could go in there and clean that up. But overall, really nice and fast. This only took about a minute, minute and a half to process. So there we go. That's our final model, and I will output it as a mesh. We will just call it foot.